If you only watched one video from the Chapter 4 series, I hope it's this one because it illustrates everything you need to know. Multi-step factoring. Well, multi-step implies that there's more than one thing to do. And all the other factoring problems we did up to this point, you did one set of factoring or one step and you were done. So this warm-up problem here, I'm not going to do the whole problem. I'm just going to point something out really quick, which is this. You always need to try the greatest common factor first. And the greatest common factor is to say, is there something that goes into all of those? And yes, 2 goes into all of them. So that's how you always start off a problem or attempt to start off. So is a possible problem won't have a greatest common factor? Yes. And that means you would skip to this and do the 2 sets of parentheses. So all these problems down below have a GCF. So understand that not every single problem is going to have a GCF, but we want to illustrate the point here. So all of these guys down here, these 6 examples, have a GCF. All right, number 1. GCF first, no matter what. I'm going to write this one time, and I'm not going to write it again. Well, C stands for common. What is common to all of those? They all have X's. So GCF does not have to be a number. It can just be a letter, or it could be both. Well, if you take one of the X's away, there would be 2 left. If you take one of the X's away here, there will be 1 left. And if you take the 1X away here, the only thing that will be left will be the 14. Now, here's what it's going to take for you to realize there's a second step, because sometimes there's not a second step. Does what's left in the parentheses look like any of the other problems that you have done factoring-wise up to this point? And that's one of the trinomial things. And the other giveaway is this guy right here. If you have a squared, then there's a pretty good chance that you can do this, or you can at least try it. So x times x gets you the x squared. And if you didn't watch the trinomial factoring videos, go back and watch them. So I jump down here to the end and I say, what times what is 14? 7 times 2 is 14. How do I get a negative 14? Well, that means one of these guys would have to be negative, and one of them would have to be positive. Now, how did I know which one was negative and which one was positive? Well, I'll show you here in a second. But I do want to drop this x down because he becomes part of the answer. So the GCF, got to write them. Okay, now, maybe I got the signs backwards. So here's how you find out. And if you watch some of the other videos, you would know this. I'm just going to check it. I'm multiplying the outside 2 together, negative 2x, and multiply the inside 2 together, positive 7x. And if I combine these 2 guys, what do I get? I get 5x. Well, what was in the middle of the problem that we were just working on? A 5x. That guarantees it's right. So the answer, if you excuse my mess, is that guy right there. So we got the GCF, and then we did some trinomial factoring. Number 2, always start with a GCF. What number goes into both? 2 goes into both. Do they both have H's? No. So that's it for my GCF. Well, 2 times what's going to give me the 8? 8 squared didn't go anywhere. 2 times what gives me the 18. Now again, recognition is the key, people. So if you recognize the fact that this is a binomial, it's a subtract in the middle, and 4 and 9 are perfect squares. In other words, 4 is 2 times 2 and 9 is 3 times 3. That's an example of a difference of 2 squares. And a difference of 2 squares goes like this. 2 parentheses, 1 plus, 1 minus. Well, what times what would be 4h squared? 2h and 2h. What times what is 9? 3 times 3. And difference of 2 squares was always 1 plus 1 minus, because how else can you get the negative 9? All you have to do is remember to bring the GCF down, and you got it. That guy's done. Okay, number 3. No numbers. That doesn't mean you can't do a GCF. What's common to all of them? They both have a y squared. So I do a GCF of y squared. Now again, really tempting to say, well, the y squared's gone and I don't need to write anything. But factoring is something times something. So y squared times what would get you y squared? And that'd be 1, right? Because 1 times anything would be itself. And what times what would give me that? Y squared times the w cubed would give me that whole thing. So there's a GCF for that guy. Recognition is the key. Did I write down a binomial, 1 plus w cubed? Yes. That has a cubed in it, a perfect cube? Yes. So that's an example of the perfect cube, which was a little set of parentheses times a big set of parentheses. So if you didn't watch that video, check it out. Well, how do I get 1? Well, the only way you can get 1 is 1 times 1. No choice. How do I get a w cubed? W times w squared. And I put the smaller one in the small parentheses and the bigger one in the big parentheses. And then to get the middle of the answer, which goes right here, you take whatever you wrote right here and times them together. So 1 times w will be 1w. And if you watched that other video, you would know what the acronym SOAP means. And if you didn't, here's what SOAP means. So this gets you all the signs for your answer. So what was the original sign in the original problem? It was a plus. So S for same. So you start off with the same as the original problem. O stands for opposite. Then you go opposite of that, which would be minus. And AP stands for add please. In other words, the last one is always positive. Just make sure you write down your GCF as part of your final answer, and that's it. Okay, I'm going to quit boxing these in because I'm getting tired of doing it. Okay, number 4. What's common? They all have A's. Take an A away, I'm left with the x squared. Take an A away, I'm left with the x. Take an A away, I'm left with the 16. Second step is going to be 2 sets of parentheses, assuming there is one. But the fact that I have an x squared tells me I can break that up into x and x. A couple different ways to get 16, but I'm thinking 4 and 4, and here's why. Now, negative 4 times negative 4 would get me that positive 16. Okay, I'm going to write it off this side because I'm losing room here. But if I multiply the outside guy times the outside guy, I get negative 4x. If I multiply the inside guy times the inside guy, I get negative 4x. And what do those two guys add up to? They add up to negative 8x, and look what was right here in the middle. So we just guaranteed ourselves being right. Well, technically, this one's going to have a third step. Here's why. We just did a perfect square factoring. X and x is a perfect square. 4 and 4 is a perfect square. And the simplest way of writing a perfect square answer is to put it squared on it and write it like that. So if you forget that detail, not a huge detail, but nonetheless, math is supposed to be simplest form. Okay, number 5. What number goes into all of them? 5. Do they all have p's? No. 5 times that gives me the 15p squared. 5 times that gives me the negative 35p. 5 times that gives me the negative 30. Recognition is the key. I see a p squared, which tells me I can probably do this. Okay, now this is an example of the a is greater than 1 variety of factoring. If you didn't watch that video, go watch it. But I still have to go something times something that will get me 3p squared. And there is that something times something. Something times something that will get me negative 6. Well, how about there's a 1 and a 6. We could go 2 and a 3. So here's a little trick to help you get to the answer faster. Is the number in the middle dramatically bigger than the other ones? And the answer is no. So I don't want to use 1 and 6 because 6 is a big number. So I'm going to try 2 and 3 because 2 times 3 is 6. Now what would the signs have to be to get a negative? 1 would have to be negative and 1 would have to be positive. Now, could you be wrong and guess wrong and put them in the wrong spot? Yeah. But if you take the time to do this, I'm going to drop this 5 down here before I forget. And you multiply the outside 2, which gives me negative 9p. And I multiply the inside 2, which gives me positive 2p. And I combine those. What do I get? I get negative 7. And what's right there in the middle? Negative 7, which guarantees we are correct. All right, guys. Always, we weren't going to do number 6 anyway, by the way, and I'm about out of time, but always try that first. Thanks for watching.